Open your textbooks to page 247, and we are going to learn about simplifying fractions. Most of this is going to be very, very easy. A brief reminder, if you will, of how we simplify. Simplifying, really, in old terminology, is to reduce, right? And to reduce something, we verify that we have divided out any common factor shared by both the numerator and the denominator. Okay? That is what a reduced fraction looks like. Okay? If we divide out any common factor of the numerator and the denominator, and then what we have left has nothing else in common, the fraction is said to be in simplified form. Let's start with example 1. Jump right into the deep end of the pool. 3a plus 6 over 3a plus 3b. Okay, first things first, let's see if we can factor anything out. 3a plus 2. How about 3a plus b? By factoring out our factors, it makes it visually easier to see. And lucky for us, 3 divided by 3 is 1, and they reduce each other completely. That means the answer is a plus 2 over a plus b. Now, remember that fractions can never have 0 in the denominator. Okay, remember that? Well, what would create this situation is if a is the opposite of b. Okay? If this is 6 and this is negative 6, that creates a 0 in the denominator, and you cannot have a fraction with a denominator of 0. Which means this answer is correct as long as a does not equal b. Let's call an exclusion or a restriction, okay? This is, we restrict the fact that a is equal to negative b, okay? That's a restriction on the variable. It's going to ask for restrictions throughout this chapter. That is what it means. And remember, restrictions on a denominator is any scenario that creates a 0. Example 2 has us looking at something a little bit bigger. X squared minus 9 over 2x plus 1 times 3 plus x. Notice the denominator is already factored. Looks like the numerator is a difference of squares, isn't it? I'm going to go ahead and begin by factoring x plus 3, x minus 3, and all of that goes over 2x plus 1, 3 plus x. By the way, this is the same as x plus 3. Okay? Positive 3, positive x is the same thing as positive x, positive 3. Which means those two items reduce each other completely. This divided by this equals 1. Leaving me with an answer of x minus 3 in the numerator position and 2x plus 1 in the denominator position. Okay? Now, I want to restrict anything that equals 0 in the denominator. So I'm going to solve for 0. Okay, I'm going to solve for 0 real quick. 2 times, okay, minus 1. Okay, so negative 1/2 can be excluded. But we also need to use this one. Even though it's been reduced out, we still need to solve this one for 0 and exclude that item. Okay? Okay? So these two items are items that x cannot equal. Okay? It cannot equal a negative 1/2 because that would create a 0 here. And it cannot equal a negative 3 because that would create a 0 here. Remember, before we even do any canceling, that 0 is already there. Okay? So 2x plus 1 times 3 plus negative 3, well, that would cause this times this to be a 0, rendering our fraction meaningless. Okay? Which is why even though you've factored, you look at what would create a 0. Okay? In both pieces. In all pieces, I should say. Example 3, what gets more difficult is just the factoring, and that's what you guys are going to have to continue to wrestle with as your career goes on. 2 minus x squared. Oh, I hate negative x squareds. Okay, I can still factor it though. All right. The numerator, factors of 6 whose sum is a negative 1, and then group. Okay, I'm just going to go ahead and give you what the result would have been. Okay, factors of negative 2 whose sum is a negative 1, I would end up with 1 minus x multiplied by 2 plus x. Okay, everybody seeing this? Now notice, this is a positive x and a negative 1. This is a positive 1 and a negative x. These two items are opposites. So if I make one of those, if I factor a negative 1 out of either of these, I then am going to be able to reduce because they will then be identical. It's really irrelevant which one you pull it out of because by creating a negative in the numerator or the denominator, the fraction becomes negative anyway. So I'm going to leave the top alone. And I am going to say negative 1 creates a negative 1 plus x. Okay, I took a negative 1 out of that. Negative 1 times negative 1 is positive 1. Negative 1 times positive x is negative x, okay? 2 plus x. Okay, this is my new fraction. Okay, now given what I have available, I can say that if I look at all of this before I reduce, x cannot be a positive 1, because if it's a positive 1, I've created a 0 here, and multiplying anything by 0 creates a 0. So x cannot be a positive 1, or if x is a negative 2, it will create a 0 in this piece. And the product of these three factors would then be a 0, which you can't have. Okay? So I've already excluded reduce. Okay? The answer is negative 2x plus 3, my old numerator, and 2 plus x. So I took this negative and I just floated it out here because either of those pieces are negative. Okay? That is example 3. Oops, I should give you a little more room. Took that negative, just floated it out here. Negative, negative 1, it doesn't matter. Negative. Okay? Reduce. Last item, example 4. You're going to say to yourself, what is the point of this? It uses what you've just learned for something that you're going to need. It says solve ax minus a squared equals bx minus b squared. Solve it for x. To solve something in a variable-looking equation that has only variables for a variable means that somehow you need to isolate that variable on one side with all of the rest of the paraphernalia on the other. So to do that, I'm going to move my a squareds to the right, and I am going to move my bx to the left. Okay? That gives me ax minus bx on the left, and I'm going to put it in alphabetical order, equals a squared minus b squared. So far so good, right? Okay. Remember, I'm solving for x, not ax minus bx. To get x alone, I can actually factor it out, and that would look like this. Anytime you have two items being multiplied, if I want to isolate one by itself, I divide out the other. A minus B. A minus B. The result of A minus B over A minus B is a 1. So now I have x equals A squared minus B squared over A minus B. Solve for x? Yes, I've solved it for x, but I am going to tell you this is not in simplest terms. Okay? It is not. Factor, this is a difference of squares, A plus B, A minus B, that should be a minus, and A minus B. Okay? A minus B. What scenario would cause this to be a 0? Well, if A and B are the same number, then it's like 6 minus 6 is 0, 2 minus 2 is 0. So the exclusion is A cannot be the same as B. Okay? Reduce, reduce. X equals A plus B. Okay? Always look at your denominator when it's almost to that final piece of crossing stuff off. Find your exclusions, list those, reduce, reduce. And what is left is x equals A plus B. Your homework for today is 6.1, 1 through 29, add. If all I see is answers, I will not give a bit of credit because that will mean that you simply copied the answers out of the back. But I do want you to use the answers to verify that you're correct.